This is Honors Algebra 2 Pre-Calculus. We're doing 10.7 in Pre-Calc, which is polar coordinates. In example 9, we're going to convert the equation to polar. Now, this is arguably way easier, and here's my reasoning. When we're converting to polar, x equals r cosine theta, and y equals r sine theta. That's it. You just need those two things, right? Now, if you want to add in one more that's useful, you could add that x squared plus y squared equals r squared. Because sometimes if there's an x squared and a y squared in your equation, that's useful, but other times it's not, and that's fine. So let's start with A. X equals 7. All I have to do is replace x with r cosine theta equals 7, and that answer is right. If you want to solve for r, you can. You would end up with r equals either 7 divided by cosine theta, or r equals 7 secant theta. Right? All three of these are okay, but you could have stopped at r cosine theta equals 7. For B, I'm going to replace the y with r sine of theta. I'm going to replace the 5 times x with a 5 times r cosine theta, and I'm going to leave the 2 as a 2. Honestly, that's a great answer. If you want to solve and clean it up, you can. There's not a huge incentive to do so. You could, like I said, if you want, but there's not really an incentive to do it. So, and then let's squeeze in C. So now C, I have two options here. I could either individually replace this x squared and y squared with an r cosine squared, like r cosine theta quantity squared and an r sine squared quantity theta, or I could just jump to the end and recognize that these guys together are an r squared, which is a lot easier. Minus 5 times an r cosine theta, because that's what my x is, equals 0, and I'm done. Again, if you wanted to try and solve or manipulate it in some way, you could, but there's not really an incentive to do so. So that's it, right? That's it.